Yes, welcome to Vision Plus and welcome back to the S.4 Mathematics. We are looking at application to kinematics, that is, calculation of velocity and acceleration. Example 1 says, Part A. Part A says, the displacement of a car from a fixed point after time t seconds is given by displacement s is expressed in terms of time, that is 18 t squared plus 4. This is the expression for displacement from a fixed point after any time t. This is the definition. Now, question A, Roman 1 says, calculate the velocity when the time is 3 seconds. Velocity when the time is 3 seconds. What is the relationship between velocity and displacement? We say that velocity is the rate of change of displacement. Therefore, v, which is the velocity, is ds dt. ds dt is the rate of change of displacement. That means for us to get the velocity, we must know ds dt. ds dt means that we need to differentiate the function of displacement s with respect to one of its variables t. So on differentiating that, ds dt becomes, if we differentiate 18t squared, we get 36t, plus if we differentiate 4 is a constant. If we differentiate any constant, it gives us 0. So plus 0, which is 36t. Now, 36t is the rate of change of displacement. And the rate of change of displacement is what we are calling the velocity. So this is the expression for the velocity at any time t. Therefore, velocity is 36t. This is the expression for the velocity at any time t. In this case, t is still a variable. When the time changes, the speed also changes relative to time. But after getting the expression for the velocity, the question says that what then is the velocity when the time is 3 seconds? So when the time t is 3 seconds, what is the velocity? We use the expression for the velocity at any time t to get the velocity at a given time. So we shall say now, therefore, velocity equals to, we need to substitute for t as 3 in the expression for velocity. So 36 t, and t now is 3 seconds. Then you press the calculator and get that velocity at time t is equal to 3 seconds. So 36 times 3, 108 meters per second, or this is the same as meters per squared second. No, meters per second, not squared. Squared is for acceleration. So that is the solution for part A. Now going to part Roman 2. Roman 2 is asking for us to calculate the acceleration. Now, what is acceleration? Acceleration is the rate of change of velocity with time. So, where is the expression of velocity? This is the expression of velocity at any time t. Acceleration is the rate of change of velocity. So we use the expression for velocity. Don't use the velocity at a given time like 3 seconds. No. Use the general expression for velocity at any time t. So we have seen that the velocity at any time t is defined by 18t. That is the expression for velocity at any time t. Now, what is acceleration? Acceleration A is dv dt. Acceleration is the measure of how fast the velocity changes with change in time. Okay? It is the measure of the change, the rate of change caused by change in time relative to velocity. So we need to get dv dt. That is the rate of change of velocity. That means we need to differentiate the function for velocity at any time t, which is 18t. When we differentiate 18t, it gives us 18 only. So the rate of change of velocity is 18. We have differentiated 18t to give us 18. Therefore, since we have said that acceleration is the rate of change of velocity, which is dv dt, it means acceleration in this case here equals to 18. Therefore, acceleration is 18. Still, this is the expression for the acceleration at any time t. Okay, it is for acceleration at any time t. Now, what have they said here? That at time 5 seconds. So now you come and say, what if now when the time is 5 seconds? What is the acceleration? Now you come and substitute for t in the expression for acceleration. Remember, this is the function for acceleration at any time t. So you substitute for t as 5. But if you look at the expression for acceleration at any time t, it is not having any time variable in it. Okay? It is not having any time variable in it. What does it mean? It means that the acceleration is independent of time. It doesn't matter what the time is, the acceleration will always be 18. So therefore, when time is 5 seconds, there is nowhere here we can substitute for t as 5. So therefore, acceleration when t is 5, it still will be 18 meters per squared second. So the acceleration in this case is independent of time. It doesn't matter how long the particle, in this case how long the object, a car, runs. The acceleration will always be 18 meters per square seconds. That is the solution to part A.